So let's come back to this problem we discussed earlier about students helping each other. Right? So we had tried to find two students who could match each other in two subjects, so that one student was better in physics, the other was better in maths, and they could study together and help each other. So each person is getting something out of it, each person is also doing something useful for the other person. But supposing there is a larger group, maybe it could be that we did it only for maths and physics, but it could be that one student can help another student with maths, that student could help a third student with chemistry, and the third student may be able to help the first student with physics. So how would we find those kind of study groups which are not just two people but maybe...
It seems to me, I mean, we discussed this earlier also, it seems that we are trying to set up a relationship between students.
Yeah, so
we are trying to see which student can mentor another student in a subject.
Yes.
So there must be some neat way of representing this relationship where one student, if there is a student A that can help a student B in a subject S, I can just say that. I mean, I can just say that A can help B in S and write that, represent that somehow.
So are you saying something like, if I have a student and say another student B, and you want to represent that A can help B in S.
In a subject S.
So I kind of draw this.
Put an arrow and put S on top.
And then because I want to know which subject it is,
label
I will write
a
label on top of it.
Something
which will
like
say
this.
That is
if I can do this,
then you think from this information we can do something?
I feel that this is very useful information for us to digest all these cards into some diagrammatic, graphical, diagrammatic.
So then when do we make this connection now? So in a subject,
we have to say when A can help B, right? I would say that A can help B if A's mark is more than
First of all, A must be knowing more than B, otherwise there's
much
no
more
point.
than B, not just simply 1 or 2 marks more.
Okay.
Let's say 10 marks more, how about that?
Yeah, but should not be too much, no? Because otherwise
that difference will be too,
yeah, A might not be able to.
So how about if we say the difference is between 10 and 20? A's mark in S.
Okay.
S is the subject, right? A's mark in S.
So A's mark
in S, subtract B's mark in S from it. So the difference basically we are saying.
Minus
B's mark in S. So if you subtract the 2 marks in S, it should be between 10 and 20, including 10 and 20, let's say. It should be between 10 and 20 inclusive. 10 can be 10, can be 11, 12, 13, that up to 20. This thing at least 10 because
there should be some substantial
some gap must be there, right? Between the two sets.
A must know.
And if it is 20 and all that, then if it's more than 20, then
A will be not able to appreciate.
So much better than B.
May not even understand B's difficulties.
So this is a good, I think this may be a good metric,
Okay. So let's try and see that. So let's do it maybe for one subject first and then, or should we, so let's try and do it say maybe for maths.
We'll do it for maths. So we are finding all pairs. So it means all pairs means nested iteration, right?
Yes. So
we'll see. Maybe we can do it better because we can reject quickly, right?
So let's see.
So for Rahul, we need to only find people who are within 9.
So I'll write down the card number
11,
so that I don't have to write down long names. So it will be easier to.
So only those people who are within.
So we are doing now only for maths.
So 97 means we are starting with 87, just 10.
And 77. So anybody who is
between 77 and 87.
Between 77 and 87 will be
candidate for Rahul to mentor.
Yes. Nobody is going to mentor Rahul because nobody can
97. So it's not possible, right? So Rahul is
going to be
doesn't need mentoring. Okay. So we have to look 77 to 87. So that should be fast to do, I hope. So we reject this, right? We reject this. We keep this.
87. 77,
77.
So
7.
So we had what is Rahul's number?
11. 11.
So we say that
for 11 the list, we are making a list, right? So 7 is the list. This is out, 97. 63 is out. This is 87, just about. 16. This is out. 81 is in the list.
6.
This is out. This is out. This is out. This is in the list.
27.
This is just in the list. 25.
This
is out. This is out. This is out. This is also out. This
21.
Is 21. This is also out. This is also out. This is just in the list. 4. We are comparing 77 to 87. Look, right? 52. This is out. This is out. This is also out. This is also out. This is also out. Out. Out.
Okay. So Rahul can mentor, number 11 can mentor all these guys.
Yeah.
Okay.
Now like that we have to do for everything. We have
Okay.
finished Rahul, we have to do Harish. But
Yeah.
when we do Harish, we can look at it again. We have to look at it again.
Yeah,
At
but
least
Rahul we know can't get it, but for other people there may be.
We
So
have
let's
to,
do.
yeah.
So Harish is 1,
So 62. So who can Harish mentor?
42 to 52.
42 to 52. Okay. So Rida 3 is out, is out, is out, 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 12. So this is a lot of work, but once you do this, I think it will be useful
Yeah.
for us afterwards, right? That's the idea, right? This is out, this is out, this is on, this is gone. 42 to 52, right?
Yeah.
Gone. This one is there.
24. Okay.
This is gone. This is gone. This is gone.
Mm-hmm.
This is gone. Gone. This is gone. 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 No. Then nothing. Okay. All right. This is a small number. So Harish is done.
Yeah.
Now we have done Rahul and Harish.
Yeah.
2 we have done. Now we come to Rida.
So I think 42 was the lowest mark. I don't think anybody has got
So we should
32. So Rida is going to, I can just put it as, I will just draw
Empty
it as
set.
an empty list.
Okay. Rida's done. Then Shashank.
Shashank will be 37 to 47. So I
Alright.
think one of them is this one, right?
So this
So
is
show
Rida.
Shashank's number.
Shashank is 2.
Shashank was 2. Then Rida is 3. Okay, I made a mistake. Okay. So 2 can now mentor 3.
And yeah. So so 2. So 97, 62 are anyway out.
Yeah.
57. So we are looking at 47.
Yeah, so maybe we'll keep that there so we remember which is on the left. Okay. Okay, now we're going 37 to 47.
37 to 47.
There are not many.
Yeah, I think we can go fast. 37 to 47. Probably none. Oh, okay, one is there here. Siddharth,
24. Okay.
37 to 47. Okay. Okay, done. Done.
Okay.
No more. So we have done
We have done 11, 1, 3 and 2.
now 2.
Yeah.
Now we
yeah.
come to 15.
50. So this is 76. So we are looking at 56 to 66.
56 to 66, we have to go back here.
Yeah.
56 to 66, this is there. Harish, 1.
Okay.
This is also there. 2.
Okay.
This is also there. 22.
Okay.
Not this, not this. Not this, not this.
No, 66 is there.
Okay.
Yeah. 10. Okay. Yeah.
13.
13. What is that one? 81. Okay. 19.
56, 19. 17.
17.
9.
That's it.
That's it. Okay.
We have done 11, 1, 3, 2, 15.
All right. We can, like that, we can do all those.
Yeah.
Presumably.
Hmm.
Um,
So maybe we can, so instead of doing the rest for now, let's see within these 5 that we have found some groups for, whether we can find some for some other subject. Should we do something? Not take these, but maybe start with the next group. So what we want to do is we want to find out, which we said was we wanted to find out whether if we go, for example, from say 11 can mentor say number 16. So 11 can mentor 16 in maths.
okay.
Then we want to find out whether it is for
16 can mentor 11, for example.
yeah, for instance, is it possible? So it can't be in maths because this
11 is greater than 16, so 16
so it can't be
there.
there. But
So
it
as
could
in
be,
physics.
for example, in physics.
Physics or chemistry.
Right? So this is what we want to find out.
So let us do physics and chemistry we will do
Okay.
also,
Yeah.
but do it only for these sets, huh?
For we should maybe leave out these 5 and start with the next 5 and see what we can do.
What do you mean by next 5?
That is, in this sequence, 11, 1, we have already looked at the first 5 cards, right?
Oh,
This. So start with the 6th card and look for now physics neighbors of the 6th card, which includes the first 5.
Yeah.
But
Okay, let's do that.
so
So Priya 22.
okay. So now we are doing for physics. Okay.
This we should finish. Offline we'll do it. I
Yeah,
think
we'll do it. Some, yeah. So 22.
22.
So in physics, so she has 62.
62, so we are looking for.
42 to 52.
So again we have to see these also, right?
Yeah.
In fact, we are particularly interested in
Yeah. So 1.
these. 1.
Okay.
All right. 42 to 52. 42 to 52. Okay, not. Right. 64, 64, 68, 69, 71, 72, 72, 73. Not likely to find, I think. People have scored well in physics. 66, 81, 82, 83, 88, 91.
Okay. 92, 92, 92. So,
Okay.
in,
So,
So
we
it's
have
just 1.
only 1. So we have found, I think, some pair, no? Have we found? See, one has got no, one doesn't have 22.
so 15 goes to 22, for example. 22 goes to 1. That doesn't. So
Doesn't help. Okay, let's see chemistry. Should we do chemistry?
Yeah,
Or we do some more physics we should do.
we can do some more physics.
Okay. So we start
So
now
let's
with
start maybe a little further down. We don't have to start at the next one. Just some.
these are all 62, 64. We'll go to some slightly higher.
Yeah. So I think physics marks seem to be roughly increasing. So we can go for somebody who's got in the 70s or 80s.
Should we say this? 71?
Yeah.
JK.
26.
26.
Well, 26 doesn't appear here. So let's take
No, why
another
not?
one.
Pick one from there.
Yeah. 10
10.
is okay.
10 will do
10 or 24. 24. Let's go for 24 then.
24. Okay. 72. Siddharth. All right.
Okay.
So 72 is, you want to do 52 to 62.
Yeah.
Okay.
So we have to
So
go
we
back.
got to go back here. Not this, not this. This one.
Yeah. 3.
3. This 2.
Okay.
Gautami 15.
Okay.
This one. Priya 22.
Okay.
Sophia 14.
Okay.
Not this.
Okay.
Not this. Right? Not this. Not this. Not this. Not this. No. No. I think all of these are going to be higher.
Yeah, and I think beyond that they're going to be above.
So if you had sorted it, hey, it would have been made our job much easier, huh? Looks like. Huh?
Yeah. Looks like.
Huh? Sorting it would have helped. Okay, here 66 is ruled out. 52
Yeah.
to 62 we are looking at.
Yeah.
So this is sorted by physics marks, I think. So that's why it's very easy to do it. Huh? Okay.
Yeah.
So that's it. We're done.
Yeah. So I'm just trying to see whether.
You're already finding a pair, seeing whether there's any pair forming.
So here, for instance, we have a pair, right?
Which is
that
2 is 24, 24 is 2.
yeah. So 2 can mentor 24 in maths,
Okay.
right?
2 is 24.
And 24
24 is in 2.
can mentor 2 in physics.
All right. So it looks like the way it works is that once you find these lists, you're making some structure here, right? Something.
Yes.
We have to see what the structure is. It looks like an interesting structure.
Yeah.
We are connecting every node to every other node.
Correct. So we could actually draw out this thing as a picture instead of these lists like we had started.
How do you
Right.
draw it? I mean, what kind of picture
So,
we get?
so I will, just like we had started doing there, so
Ah.
I could draw this whole thing out. So let's keep this. So I would say, for instance, that let's just write these numbers. So I have 11, say 1. Okay, so I would say, for example, 11 connects to 7.
Okay.
And separately, it also connects to
16.
16.
Okay.
And
Like that
then
it connects to 6.
connects to 6.
There are many connections.
So 11 has many connections like this. Okay, but let's look at the other ones. So
You got
one,
two, because you got two.
yeah, so let's start with, these are smaller lists, so that's probably easier to draw. So one connects, so this is all the maths connections. So one connects to 3, one connects to 12, one connects to 24.
Okay.
And now 2 also connects to 3. Right? So one connects to 3, 2 also connects to 3.
I see, okay.
And 2 also connects to 24.
Oh, I see. Oh, like that.
So we will have one of these for every, because every card has one number, so it will come only once in this. Right? And now when we go back and do the physics marks, for instance, for
So
24 is the same 24, then we will say that from 24 we will draw a physics line, a physics arrow back to 2, 3.
2 3s also there?
Yeah. So 3, 2.
Oh.
And then 15, which we have not drawn yet, but somewhere there is going to be a 15. And a 22.
15 is there?
No, 15 is not yet drawn in my picture
okay,
here.
okay.
And 14 also I have.
15 is connected to 1. 1 is connected to 24. 24 is connected to 15.
15 is connected to 1. Ah, yes, by maths. Right?
So 15 can mentor 1 in maths.
Hmm.
1 can mentor 24 in maths. And 24 can mentor.
15 in physics.
You notice that there is a cycle here? Just
Yeah.
like this. This is a cycle, this is also a cycle.
Yeah, a longer cycle. So like they can form a group.
So a cycle, but this is not a cycle. 1 is mentoring 3, 1 is mentoring 24, 24 is mentoring 3. But this is not a cycle.
Yeah, because you go backwards across this arrow.
You're going, you should go only in the forward direction of arrow.
Yeah.
So similarly 2, 3, 1
This is not
is
good. You can't go from 2 to 3 to
2,
1.
3, 1, 24, 2. It
Yeah.
looks like a cycle, it's connected, but
Yeah.
it's not connected in the same direction.
Yeah.
It's going the opposite direction.
Yes.
But here if you look 15
Hmm.
to 1
Hmm.
along the direction of the arrow,
Hmm.
1 to 24 along the direction of the arrow,
Correct.
24 to 15.
Yeah. So we have this, basically this kind
So
of.
is that correct? I mean 15, who is 15?
15 was the 5th card. Hopefully it's still the 5th card.
Yeah, okay. I didn't shuffle it, so.
Yeah, after 2 there.
15. Gautami,
Hmm. So Gautami has 76 in
maths, and is able to
Mentor
mentor
one.
Harish,
Who has 62.
who is 62,
Yeah.
and who
Harish
is able
is
to mentor
24, which was way down.
24. 24 Siddharth.
Who has
I'm
40.
just going to take out these cards.
Yeah.
Looks interesting, huh?
Yeah.
So
1, 15 and 24. You need to get 15 out, which is after the 2.
after 2 is 15.
Yeah.
So
So these are the 3 cards.
how did we say it does?
I
76?
think you're outside the view of the thing. So we should probably put them here. So now what we claimed is that 15 can mentor 1 in
15
maths.
can mentor 1.
That's because this difference is between 10 and 20. 76, 66, 56. So this is in the right range. Now 62 can mentor something between 42 and 52. So this can mentor this.
Oh, I see.
But now 72 can mentor somebody who's got between
52 and 62.
So coming back,
Physics.
physics.
So Gautami can mentor Harish in maths. Harish can mentor Siddharth in maths.
Yes,
And Siddharth can mentor Gautami in physics.
yes,
Interesting.
yes.
So we are finding cycles, right?
Yeah, so we're
Looks
finding
like
these
you're
kind of
finding
cycles, and the cycles typically will have different colors in the sense of different subjects.
In this case, of course,
Yeah.
there are both are
Yeah,
the same.
2 are in maths.
This is not a desirable cycle in
Yeah.
a sense, because
Yeah, so ideally you would like a cycle which looks like,
if you put different colors,
yeah, so we would have, I have only 2 colors, but you would like somebody, say 3 people A, B and C. Right?
A mentoring B in one subject.
Yeah, so supposing A is good in maths and mentors B, and maybe B is good in chemistry and mentors C, and C is actually good in physics.
So cycles of length 2 also is okay.
Yeah, so length 2 we already saw, like this
This is
one,
like 2
maths
and
and
24.
physics.
So length 2 or length 3 cycles
Yeah, will form study groups
form study groups.
where they can help each other.
So is there a name for this structure which you have created, this kind of diagram which you have made, this diagram?
This diagram, yeah.
This
So
diagram.
this, yeah, so this actually is what we call a graph.
I see.
So this is not the kind of graph that we study in
That
maths.
X, Y.
Yeah, so this is not a graph.
We draw the
It's not a graph like
axis.
this
Not
of
that.
some function or something like that. This is a graph which has these.
But those, this also a relation, that is also a relation.
Yeah, correct.
So in that sense,
Yeah. So
graph
what we
is a-
have is we have these. We
but
have
this is a discrete, this is some
Yeah.
more continuous thing.
correct.
This is a very discrete thing.
Yeah. So you have these things where we, in our case, these are students. So we put some labels like 1, 15.
What are they called, these things? Round
22,
things?
right? And so normally we will call them, either we can call them a node or we can call them a vertex
Okay, of the graph.
of the graph. So these are the items that we are trying to connect.
Okay.
These are things we are trying to relate. So here for us the items are the cards corresponding to the students, and then we draw these connections between them, right, in different directions and so on. And these are called edges, right? So edges connect these nodes.
And I noticed that you put a arrow.
Yes.
So presumably these edges have a direction.
Yeah, so here these edges have a direction which says that one
they're
can
directed
mentor
edges.
15. So there,
Direction-
yeah, so
directed
there is
edges.
with a direction in this case.
We
But
have
you
no
might
idea.
also have situations where you don't have a direction.
Okay.
Right.
All right.
So we can maybe look at that in some other
Okay.
problem.
In this one there is a direction, and the direction means something. It means 1 to 15 means that one can mentor 15.
Yes.
And you also put a label, right? We have a
Yeah,
label.
and the last thing we put is a label. So we put something here like maths or physics.
So it's a labeled edge.
Yeah.
So you have an edge with a direction and a label,
Yes.
right? So graph which has nodes or vertices connected, the nodes are connected by directed edges which have labels on them.
Yeah. So the nodes themselves have labels in the sense that the nodes have
Nodes
names,
have
names which identify. Otherwise, you can't tell.
You
which
can't tell
node.
which node is what, right?
And
So
then you
nodes have-
connect pairs of nodes by edges. So you can say from 1 to 15 there is an edge labeled M,
M.
or from 22 to 15 there is an edge labeled P.
And what we are looking, so this graph is easy to construct because all you have to do basically is inspect the cards,
Yes.
and if you find that in any subject between the two cards, the marks is lying between 10 and 20, then you draw this edge.
Yes.
If it doesn't, then you don't draw the edge. So it's easy to draw these edges, and it's possible that between 22 and 15 there are more than one edges.
Correct.
So you could have
Yeah.
physics, maths and chemistry all pointing in the same direction.
Yes.
So
Correct.
for example, if you take Rahul,
Yeah.
chances are that there will be many edges going out from Rahul.
Yeah. Because he has high marks, so there
And
will be
everything, right?
Yeah.
It's possible, but also it's possible that there are edges going back from 15 to 22 also.
Yes.
Right? But you cannot have one P going from 22 to 15, another P going from 15 to 22.
Yeah. Because one, if it's bigger in one direction, it has to be smaller in the other direction. So then the edge cannot.
So
be
it's
there.
not
Yeah.
it's not possible also that there is a cycle with all P's.
Correct.
22 to 15, 15 to 1, 1 to 22.
Yeah.
Not possible
Yeah. So
because
this cycle, for instance, has 2 maths and then
one
one
physics, that's possible.
But you can't have 3 maths.
3 maths,
Because
because
that would mean that
it has to
15 is
keep on
bigger than
increasing.
1 is bigger than 24. It's again bigger than 15. That's
Not possible.
Not
It's a
possible.
paradox. It's a contradiction.
Yeah.
Right? So
So any cycle in this particular graph that we are drawing with the subject thing will have
cycle will have some fixed length only here because I mean you're increasing by 10 marks.
yeah.
So
Yes, you cannot go on indefinitely because if you go across this, you are at least 10 marks less,
Less.
at least 10 marks less, at least 10 marks less. So if you are across say 6 steps, then you have gone down 60 marks, and probably nobody has got less than.
So you will have some number of edges with them, and then after that you can do physics some number of edges
Yeah.
like that. So you will have only some length cycles, but anyway it could be quite long. We don't
Yeah.
know. But right now we are interested in finding cycles which are maybe of length 2
Yeah, or like 3.
or length 3.
Yeah.
Ideally 3.
3, but 3 we would actually like this kind of
Different edges.
we like this kind of cycle. It's not very useful, I think, to have a study group where a student, say the number 1,
Huh.
is both learning maths from one
And also teaching maths
to
because
another.
this guy will feel bad.
Yeah.
Imagine the study group 24 is going to feel terrible, right?
Yeah, because he's
already
getting second hand information even
it looks
within
like
the
that.
study.
Yeah, no, we
So
don't
this
want
is the kind of group we would really
Ideally
like.
we'd like
yeah.
that group.
So what
so
we
which
would
means we are looking for cycles of length 3.
yeah, in the big graph. which we had done this whole
cycles of length 3 with all 3 different labels.
With 3 different labels, yeah.
Or cycles of length 2.
Yeah. Or
if there are cycles of length 2, will always be different labels.
Yeah. So in this graph, for instance, we know that all the cards are numbered 0 to 29.
Yeah.
So we would have, effectively, we would have these 30 different vertices all the way up to 27, 28, 29. So we would have this, and then as we examine the cards, we will start inserting these edges.
Edges.
This is maths, or this is physics, or so on. And then in this picture that we can't build from this, we would then start looking for these interesting cycles.
So if you want to find, so what's the method of finding the cycle?
Well, you can start with some guy.
Randomly you can start.
Start somebody and see, pick a neighbor.
Pick a neighbor in the sense that it
somebody who can
connected.
Student whom that person can mentor.
By looking at this graph.
Yeah.
Graph itself here looks like it's an easy way to maintain the graph because all it does keeps the lists.
Correct.
It's
for each label, we keep a list of neighbors on outgoing mentor possibilities for that label. So these are all the math students whom 11 can mentor. Similarly, these are all the physics students that 24 can mentor.
So you just bunch
so
of
we'll just have 3 lists for everybody. The list could be empty, like 3 can't mentor anybody in maths. This could be only one item, or the list could have many items like this, depending on how many.
So you have 3 lists. So 3 basically has, if you take 3, it will have a list of students that 3 can mentor in maths, can mentor in physics and can mentor in chemistry. So 3 lists. Like that for every node, which means for every node being a student, for every student or every node, we have 3 lists of, they are called adjacencies, or what are they called?
It's called
adjacency.
Adjacency.
Adjacency list. Neighbor list.
Yeah. So
list of neighbors.
Yeah, adjacent people who are next door.
Next door, adjacent.
Yeah.
So neighboring list. So neighbor, list of neighbors of thing. And now you are also labeling the neighbor.
Yes.
Not only
maths neighbor,
physics neighbor, chemistry. So you have 3 lists of neighbors for every node, and that is a graph.
Then we can draw it as a graph.
You can draw it out as a graph because 3 may have a neighbor which is 4, and 4 may have a neighbor who is 7, 7 may have a neighbor who is somebody else, and that guy might have a neighbor who is again this person again. So it can come back, and that's how you get a cycle, right? You get a cycle going around. And what we are interested in is finding these cycles because you want cycles of length 2 or cycles of length 3.
So these are the study groups that we.
So those are study groups. So to do that, if you want to do that systematically, you're saying start with some random node.
Well, there's one way. Start with the first node, for instance.
Okay.
Then you pick, say, a maths neighbor of that node.
Find a neighbor. Okay.
So that will have some subject. So now we want to find a neighbor of the next person, which is not the same subject, because we said that we don't want this kind of a group which has 2 edges at the same time. So if you have chosen maths the first time, you have to find a neighbor who's, say, a physics neighbor. Then you have to see whether one of those guys has a chemistry neighbor back.
So basically you are searching for cycles.
So you are searching for cycles, but you have to try it out for every.
First you can try 2 pair cycles of length 2, which is easy actually. Then I just have to find a neighbor in whose neighbor list I am lying.
Yeah, in a different subject. Yes,
in a different
subject. It has to be different subject.
So if I start with a neighbor in maths, then I look in the physics and chemistry neighborhood lists of that node to see whether I am present in that.
Yes.
If I am present in that, just like the train we saw, no?
Yes.
So if I am present in that, then
we can form.
Then I can form a pair.
Yeah.
And so once I form a pair, I take that pair out.
Yes.
I can take it out.
Take it out.
Like that, I can keep taking out. And eventually, hopefully, everything will get caught.
Yeah.
Some guys might left out. We don't know.
Huh? Then we have to go back and start again.
You don't have to start again.
Yeah, but that's a different question. I mean, how do you find the best kind of groups with this to make sure nobody is left out?
So if you want to find the best groups, one way would be to find a set group. First, find a
group. Yeah.
Find a study group. That means all these pairing cycles you find. Extract all the cycles. Write down the cycle somewhere. Then come back and do the whole thing again.
Yeah, start with a different place and see how it
evolves.
Yes.
Right? Maybe this is better than that. Maybe this is worse than that. I don't know.
Yeah.
If it is better than that, discard that and keep this.
Yes. So for each starting point, so we can even do it once for every starting point. So it will take a lot of time depending on how many nodes we have. But in principle, we can try and do this for every possible.
This is interesting. I mean, what we have created is an interesting data structure, right? I mean, this looks like a very interesting thing because a lot of information is stored in a very compact form, right?
Yes. So this picture actually captures a lot of information, these relationships between these cards. The cards are our nodes, and the different types of relationships. So not just one type of relationship, but different types of relationships we have.
All captured, and we're using all of it together to find something,
Yes,
right? Meaning?
yes. So and yeah, so what we are trying to calculate or compute is actually something to do with the structure of these relationships. So that's and we can do it much neater when you have the relationships drawn out for us, like rather than go back and look at each card because that's what we had done the first time when we were doing this mentoring. We were trying to look at 2 cards and decide whether this is bigger than that, that is bigger than this. And so once and for all, that information is captured. In this picture, and then we can
As a form of a graph.
Yes. So these graphs are very useful.